Assalamualaikum friends, I hope you are fine during this difficult time. So here we have new topic, Lagrange multipliers, which is a part of constant optimization. Optimization is a field where we want to maximize or minimize our model in terms of desired result. So contents of the videos are methodology and example. I hope you will watch this entirely, and if you like, then subscribe my channel. Let's start with the methodology. Step number 1, make a function L equals to f, which is a given function which we want to maximize or minimize, plus summation lambda I. Lambda I are also called Lagrange multipliers constant, and phi I are constant or conditions with given function. Keep in mind all phi I should be equals to 0. Step number 2, find derivative of L with respect to xi, where xi are the independent variable of f, and also with respect to lambda I. Make them equals to 0 and find critical points. Use this critical point in step number 3. Make a Hessian border matrix, which is looking like this one, where this is null matrix, and this will be in example you will understand. And make determinant equals to 0. If mu is constant, if mu is positive, then the critical point is minimum. If mu is negative, then the critical point is maximum. So this is the simple methodology of Lagrange multipliers. Here we come with an example. Friends, we have one example. Now we applying the procedure. So first of all, step 1, L f plus lambda 1 phi 1 plus lambda 2 phi 2 equals to x1 squared plus x2 squared plus x3 squared plus lambda 1 x1 plus x2 plus 3x3 minus 2 plus lambda 2 5x1 plus 2x2 plus x3 minus 5. This is our Lagrange L function. Now the second step, making L derivative with respect to x1 equals to 0. So the derivative of L with respect to x1 is 2x1 plus lambda 1 plus 5 lambda 2. Derivative of L with respect to x2 equals to 2x2 plus lambda 1 plus 2 lambda 2 equals to 0. Partial L by partial x3 equals to 2x3 plus 3 lambda 1 plus lambda 2 equals to 0. Partial L by partial lambda 1 equals to x1 plus x2 plus 3x3 minus 2 equals to 0. Now last one, partial L by partial lambda 2 equals to 5x1 plus 2x2 plus x3 minus 5 equals to 0. So here we find our all derivative. So now we have system of 5 unknowns and 5 equations. So you can solve it using any technique which you like. I have made one video about to solve this problem using reduced row echelon form. So if you have any trouble to find the point, so you can watch that video. So I find the critical point, which is 37 by 46, 8 by 23, 13 by 46, minus 2 by 23, minus 7 by 23. So HB equals to null matrix P transpose Q minus mu I should be equals to 0. So what is P? P is the matrix of partial phi 1 by partial x1, partial phi 2, partial phi 1 by partial x2, partial phi 1 by partial x3, partial phi 2 by partial x1, partial phi 2 by partial x2, partial phi 2 by partial x3, 8. This critical point, saying x naught or lambda naught is a critical point. So here we have this critical point. We have to find P at this critical point. So here is phi 1 and phi 2. Let's make a P matrix. So partial phi 1 by partial x1. So it is 1 partial phi 1 by partial x2. So again 1, partial phi 1 by partial x3, so it is 3. Now partial phi 2 by partial x1, so 5, 2, 1 at x naught lambda naught critical point. So this is our P matrix, the transpose. Now we have drive our P matrix. Let me write it here. 1, 1, 3, 5, 2, 1, and its transpose will be 1, 1, 3, 5, 2, 1. This is null matrix, so it will be 0, 0, 0, 0. Now what is Q? Q is a Hessian matrix again. You can say that Q is a Hessian matrix and defined by like this one: L x1 x1, L x1 x2, L x1 x3. The derivative of L with respect to x1 x1, and similarly x2 x1, x2 x2, x2 x3, x3 x1, x3 x2, x3 x3. So I have drive my L. The result will be 2, 0, 0, 0, 0, 2, 0, 0, 2. So this is our Q. This is also called Hessian matrix. So rewrite this one. Now the determinant of this Hessian matrix 0, 0, 0, 0, 1, 1, 3, 5, 2, 1, 1, 1, 3, 5, 2, 1, 2 minus mu 0, 0, 0, 2 minus mu 0, 0, 0, 2 minus mu equals to 0. Now it is very tough to find the determinant of this matrix, so I am going to use here a property. So I am going to make this determinant should be, this row should be 0. So R3 minus 5 R5, and here R4 minus 2 R5. So let's make changing. So this will be 0, this will be same, this will be same, and this will be minus 2 plus mu, and this row 3 here will be minus 5, 3, 15, so here will be minus 14, and in this row this will be minus 5, this will be 0, 0, 0, and 2 minus mu same, and minus 2, 2 minus mu. Here it's not same, it will be minus 5, 2 minus mu. Now for this, minus 14 should be equals to 0. So first we have to add R4 divided by minus 5. So this will be 1, same, same, and this will be divided by minus 5, and this will be plus. So now this 14 should be 0. So R3 plus 14 R4. Now this minus 14 equals to 0. This will be same, same, and this will be 14 divided by minus 5, 2 minus mu, and this will be 18 by 5, 2 minus mu plus 5, 2 minus mu. So if this row should be equals to 0, so all these entries must be equals to 0. Now let's see what happened. 2 minus mu equals to 0 implies that mu equals to 2. Here we get mu equals to 2. From this entry, 14 over minus 5, 2 minus mu equals to 0 implies that mu 2 minus mu equals to 0, mu equals to 2. Now from last entry, 28 over 5, 2 minus mu plus 5 2 minus mu should be equal to 0. So this is minus 5. This is minus 5. So after getting it equal that side, this will same, and this 5 and this 5, 28, 2 minus mu equals to 25, 2 minus mu. This will be 56 minus 28 mu, and 50 minus 25 mu. So I'm shifting this 56 minus 50 and 28 mu minus 25 mu. So this is 3 mu equals to 6, implies that mu equals to 2. So from all these entries we find on a single value of mu, that is 2, and which is positive. Mu is greater than 0, implies that the critical point x naught lambda naught is minimum point. I hope you like this, and if you have any query you can ask in comment section. Thank you.